Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we'll be looking at a topic that is a little bit challenging, not necessarily challenging, a little bit tricky. Let me use a very nice word there. A little bit tricky topic there of in physical science, specifically more on paper one, right, which is physics. So we call this vertical projectile motion. This topic is inherited now from grade 10, where we are doing kinematics in one dimension, right? But now in this case, yes, it's still kinematics in one dimension, but now we're gonna be changing the motion, okay, in which we will be dealing with. Okay, in kinematics grade 10, we're dealing with horizontal, but now in this case, projectile motion, as the name says, now it is vertical. So now we'll be looking at a trajectory, all right, or rather a path that will be rather now occurring in the vertical motion. Okay, so now this just tells you tells you about the path that you're gonna be looking at. All right, projectile, projection. It is now what can I say about projection? Projection, it is now as saying now, when you project something, okay, it has something to do with now giving an initial velocity, okay. Yes, projectile, then motion is just motion, okay. Yeah, motion is just motion. Now, okay, the motion that we'll be dealing with now, it is now free fall. Most importantly, the motion that we will be dealing with now, it is now what we call free fall, okay, the type of motion that we'll be dealing with. Now, projectile is just about giving initial, okay, velocity. It is now, remember, when you project something, it's like maybe when we say you project, it is when you are drawing something, but if you're drawing it upwards, we rather use the word project. Okay, you're projecting it to yeah, whatever the word that suits best there off. Okay, now I want us to focus more, or rather be in a position of now understanding the word free fall. Okay, the other thing is like path. This is just a vertical path. Tells you it's gonna go up and go down. That's what is referred to. Projectile, we'll discuss that in furthermore. Now let's talk about projectile. What exactly is free fall? Okay. What exactly is free fall? Now, it is a definition that is very, very important. I'm not sure if my English is correct. You know, sometimes the English likes to go away. Let me look if the definition is correct thereof. Okay, I'm not giving, but it's fine. Free fall, okay? I think they even like to combine it. Free fall. Let's say free fall. Okay? Free fall now, it's gonna tell you more about what we're gonna do, especially now in this topic, okay? Now we say free fall, it is now motion of an object under the influence of gravitational force only. What do I mean by that? Remember, I said free fall. The type of motion that you'll be dealing with now, it is now what? Free fall. Now, free fall, we are saying it is what? Motion of an object. Okay, very important. This is just the motion of an object under under the influence of what? Of gravitational force only. It means now that object will be talking about thereof. That object that we'll be talking about there will be now under the what? Under the influence of gravitational force only. What do we mean by that? Okay, let's have now a case scenario, a very interesting one. Let's say now we have a ball. Let's say this is now a ground. Okay. I want you to, I'm gonna make you to understand at least basics of now a vertical projectile motion. I do not want you to cram anything. Okay. If this is the ground, let's say now we have our ball here. Okay. Which was projected upwards like that, then came back where it was projected. I want you to see something. Remember, when we project something, we know it's going to go up like that and come back straight downwards. But now, for the purpose of explanation, we will now consider this as that trajectory motion, okay? So this is a parabolic shape, okay? Just a parabolic shape, a nice one there, okay? Now, what happens? Now, let's say now our object is moving from this point. It is being now projected or rather thrown upwards, okay? Now, what happens? I want you to take note. Remember, your object will move upwards, but now what will happen to it? It will come back. Now, the question is, what causes our object now to have different velocity to come back rather than now going forever upwards thereof? Now, this brings us to a concept now thereof of what? Of a free fall. Now, this is where now we talk, all right, this motion that we are talking about now, it is under the influence of what? Of gravitational force only. What do I mean by that? As our object is moving upwards, it experiences now a gravitational force. Remember, gravitational force always, not sometimes, acts downwards. Now, it experiences a gravitational force that acts downwards. Okay? So that gravitational force is the one that causes now my object to do what? To now come back. Okay? Let me quickly do that. These are the FGs. Okay? Irrespective whether you are going up or you are going down, FG is still gonna act down with you. Okay? Okay? Now, here's what happens. Let's say it starts at the okay. Let's say it starts at a velocity of 40 months. Like well, 49. Okay. It starts initial velocity of 49 meters per second. Now remember, what causes now this object to have now a gravitational FG? Now we introduce something that we say, okay, it experiences an acceleration which is g of what? Negative 9,8 meters per second squared. Now this acceleration, which is now gravitational acceleration in this case, it is now what? Acting downwards. So acting downwards with what? With a value of negative 9,8 meters per second squared. This is a constant number. Okay? So it means now as our object is moving upwards, it's going to experience that gravitational acceleration force, which is going to do what? Which is going to reduce this velocity now. So if I subtract now a 9.8 there, we'll get something like 39.2 maybe. Okay, 39.2 is 9.2, then we get something like 29.4 here. Can you see now as it moves upwards, what happens? Can you see now as it moves upwards, what happens? Okay, I think I had a bad start. Let's start at okay. Uh, okay, it's fine. Let's start at 39 rather. Okay, 39.2. Let's start at initial velocity of 39.2 meters per second. As I go upwards now, I go toward 24.9, 24.9, I mean 29.4. Okay. Then now, as I go up, it is now experiencing the gravitational acceleration of how much? Of negative 9.8. This is just an explanation. We haven't done anything, calculations or what. This is just an explanation that is going to be very important as it reaches here 9.8 meters per second. Then, and it reaches here, the velocity is 0 meters per second. Okay? The velocity, this is what we refer to as the maximum height. Why do we refer to it as a maximum height? Can you see now it is the maximum height that this ball can reach? Why? Because now the velocity thereof it is how much? 0. If the velocity is 0 at this point, it means now the only thing that it can do is just go back. Okay? Yes. Now I want you to see something. As we move downwards now, it is still moving under the same constant acceleration that is moving downwards, right? So now it means now here, instead of having positive numbers, we'll have negative 9.8 meters per second. Here we'll have negative 19.6 meters per second, then negative 29.4 meters per second. Now, final velocity, it will now reach negative 39.2 meters per second. So now this tells you now that, okay, the velocity now in the same place, okay? It started here, then it ended there, right? It started here, then it ended there. Can you see now the velocities are the same in that position? The velocities are the same in that position, but now what differs is the sign. Similarly, here is the same position as that, just that on this side it's coming back. Okay, on this side it's going upwards. On this side is going downwards. Okay, but now one important thing, always downwards. Okay, gravitational acceleration, this one, always act downwards. Very important. Very, very, very important, this one, okay? This one always acts downwards, the gravitational what? Acceleration. Now, the other conditions that you are going to be needed here is that there will be no friction, okay? We'll be ignoring the effect of friction, the effect of anything. So we'll just say the only force acting on this object in this particular method is what? Free gravitational force. The only instance in which gravitational force will not be the only object acting on the ball, it is when now we are moving in a hot air balloon, which we look in later on as the video possesses or progresses. Okay. So now we have kinematics equations that we will be using. We'll be using now, and I want you to realize something. Can you see now, as my velocity changes now, it means now each and every quantity that now depends on a that depends on velocity will change. Meaning now I'll have these vectors changing during the motion. Okay, I will have these vectors. The first one, momentum. Momentum changes during motion. Why? Remember momentum. Why? Because now the velocity changes. So remember, if the velocity changes, the momentum also changes. Okay. Another thing that will change, it is kinetic energy. Yes, it will be conserved. Mechanical energy will be conserved, but now the kinetic energy will change. Another thing that will change, it is potential energy. These are for multiple choice. Now, remember momentum, it is P is equal to mv. The velocity changes, right? Kinetic energy, it is half mv squared changes, right? The potential energy, which now we refer to as U or EP, is now what? mgh. One might ask, oh, all right, how is potential energy changing when velocity is the one changing? But now, can you see now the height also? Okay, the height also from the point of projection is changing from 0 position to H max. Okay, can you see now that the height is changing there of years? So that is that. Now let's consider now equations of motion. Okay, equations of motion. Motion. Okay, the first one that we'll be looking at, it is just the basic formula. Let's say V final is equal to V initial plus what? Acceleration changing time. Second one, we have Vf squared. It is equal to Vi squared plus 2a change in y. Okay. Then we have change in y is equal to Vi change in time. This one is always, or appears most of the time, plus half a change in time squared. Then we have the last one that we really use. Okay. That says now Vi plus Vf divided by 2 multiplied by change in time. This one we really use. So now, what does each letter represents now? We have check. We have 5 letters, okay. But what you need 3 knowns, okay. You need 3 knowns formulas, not formulas, known variables. Then you can get the fourth one. What do I mean? We have change in y, okay. Change in y, change in t, vi, vf, and now this one I stated it a. Now this one is what we refer to now as displacement, measured in meters. Okay, this one, it is now what we refer to as time, measured in seconds. This is initial velocity in meters per second. We have now final velocity also in meters per second. And now lastly, we have gravitational acceleration. That is meters per second squared, and it has a value of 9.8 meters per second squared. It is moving downwards, okay? I'll just say down. Okay, I don't have enough space, but it is acting downwards thereof, okay? Now, I say to you, this one you always have this one, right? You always have this one. You need 2 knowns. You need one that you'll be looking for. Let me make an example. Let's say you have this one, and each and every formula has initial velocity. So it's either you have this one or you need this one. Let's say you have this one you already have, right? This one is always there. It's always constant. You should always remember this. You have this one, and then you have this one. They say find final velocity. How do you choose that? You come to the first formula, you say, okay, they want final velocity. Okay, here I have what? Initial velocity. Okay, I have acceleration, I have time, I have, no, I do not have time, I do not use this. I come back, they want final velocity, yes, initial velocity I have, acceleration I have, change in y I have, I use this. Why this one is not applicable? Because now I do not have what? I do not have time. Why this one? I do not have time. So this is one of the ways in which now you use to do what? To check the suitable equation thereof. Okay. Yes. All right. Now let's move into interesting stuff. Scenario number one. For now, I won't be that dwelling more or in terms of examples, okay? I want to dwell more in terms of examples now, for now, but it will be important if we have some examples, but what I want you to understand now, it is a concept. I feel like when you understand the concept, it is very easy now to do your calculations. Okay, let's have scenario number one. Okay, scenario number one says the ball is dropped from a certain height above the ground. Okay, now there are very important weights that you are looking for. Sorry, during calculations. Okay, let's drink water. All right. There are very important words or keywords that you're looking for when you are reading a scenario, right? And another thing, you should be in a position of knowing how to draw the trajectory. What do I mean by the trajectory? The path that is taken. All right. First thing first, this is a keyword. Dropped. When something is dropped, it means now its initial velocity. It is 0 meters per second. It was not thrown downwards. Okay? It was not thrown downwards. Okay? It is rather dropped. Okay? It is rather dropped. Okay? Yes. All right. Now, let's have a scenario that shows us that maybe. Let's have a sketch. Have a sketch. And this particular person thereof does what? Rolls the ball downwards. Okay? Or rather drops, sorry, the ball. Remember when you try to draw, we do not say, okay, it drops the ball and we say the ball will move like this. We try to make the ball move in a parabolic shape, okay? Yes. Then this will be the ground. Okay? Then here's that particular ball until it reaches the ground. Okay? This is the case that we are dealing with of certain height h. Now, what I like to do, sorry, my English data is gone. I automatically draw the graphs of this one. Why? It is easy to draw the graphs. Okay, we have three types of graphs. Velocity time, okay, displacement time graph, velocity time graph, acceleration time graph. The easiest one, it is acceleration time graph. The second easiest one, it is what? It is change in y or position time graph. The tricky one, it is now position. I'm going to tell you this. Let's draw these graphs on these scenarios. Okay, let's start with acceleration time graph. Okay. And tell you what, you see now where your object, the scenario says now the ball is dropped. Okay, so if the ball is dropped, it is dropped downwards, right? So we're gonna take downwards as positive. Choice of direction, it is very important when you are doing this topic. Now, do you agree with me? When you choose downwards as positive, the acceleration will be 9.8 meters per second squared. Why? Because we are choosing the direction in which it is moving at. Okay, if we chose upwards as positive, the acceleration will be negative 9.8 meters per second squared. Why? Because now it is acting downward, but now we chose what? Upwards as positive. That's the most important part. This is the acceleration, meters per second, time graph. So now this is just a straight line. So we chose downwards as positive. So it means now A is positive like that. So it means it will be just a straight line here with a value of how much? Just a value, just say 9.8. You are done. You are done. Okay? This is acceleration time graph. We move on now to what we call a change in Y time graph. Okay, position time graph. Allow me to draw it here. Okay, let me repeat that. Now, this one you really asked this one, but I want you to know it, okay? One might wonder, why am I drawing it like this? Because now I know that this is time, okay? Let me label my graph. This is time, then this is position change in Y, in meters. What I want you to take note of, can you see now how the trajectory is here? It starts here, then it goes there, okay? It starts from 0 position or whatever height thereof, then it goes there, okay? So now when I draw this graph, if I chose downwards as positive, okay, if I chose downwards as positive and my object is moving downwards, so it means now I'm choosing the positive direction to be the one that my object is moving at. So I'll just say, okay, here I think I made a mistake in terms of my drawing. I want you to understand this. As my object now moves from this point, going there, I want you to check what happens with height. Let's say height here, it is 0, okay? As I move downwards, can you see now my height is increasing? Because this is the initial height, okay? Initial height, we take it as 0. Then can you see now what is happening to my height? It is increasing. So it means now my object will start at 0 position. You will not do this dot. We'll start here at 0 position, and it will move in a trajectory motion. Do not do this arrow like this, like that, until it reaches the what? The highest point. Let me repeat that. Like that. Okay? If we chose upwards as positive, it was gonna in case take a what? Take a different direction. Okay? Yes. This one should be just a basic graphs. Okay? The ones that I'm gonna explain more thoroughly are the ones that are gonna come. Let's do now velocity time graph. Yo, velocity time graph. I want you to see what happens now as time goes on now, what happens to our velocity thereof in meters per second. Now, do you agree with me that as we are moving downwards, the velocity increases thereof? Okay? Remember, it was dropped, it started at 0. The velocity started at 0. Why? Because it was dropped, okay? And when something is dropped, remember we said it has an initial velocity of 0. So if it is dropped now, for it to move downward, it is gaining what? It is gaining a velocity, but where? In the negative direction. But no, choice of direction is that down is positive. So it means if it is moving downward, it means now it is moving in the positive direction that we chose, okay? So it means now my object will say now, okay, we are moving from 0, but as time goes on, the velocity does what? Increases. Like that. Let me try to say the velocity increases. It is a straight line. This is just a horizontal line. This is a parabolic shape. Then this will be just a diagonal shape. Okay? All right. Let's have scenario 2. Now, this is where interesting stuff starts. This is where interesting things start. Scenario 2. Scenario 2. Remember scenario 1 said now the ball is dropped from a certain height, right? But in scenario 2, instead of saying that, we want to say now object is thrown upwards and caught in the same position that it was thrown, that it was thrown from. Okay, so now object is thrown up and caught in the same position that it was thrown from. So now what does that mean? This means now, okay, let's say we have a boy here. Okay, this boy now uh, rolls the ball upwards. Okay, remember when he throws the ball upwards, we try to make a parabolic shape, right? So now assume that the very same position here is the position of the boy. Okay, same boy. At the same position. Okay, why am I doing it like this? I'm trying to say now it goes upwards like this and go and comes back. Can you see it's gonna be a messy? So now when the ball is thrown upwards from a particular height and now comes back. Now, how are we gonna draw this? Okay, I'm gonna need to move these towards the side. Sorry. Okay, I'm gonna need these to move. Ish. Okay. I need them here on the side. Then similarly here. Cool. Thank you very much. Okay, this is not important. What's important is that it is thrown upwards and caught in the same direction. Now let's start. I said when you choose the choice of direction, choose it with regards to where your ball started moving. Can you see now your ball started moving upwards? So you're going to choose what? Upwards as positive. Okay. Therefore, if you choose upwards as positive, our acceleration in this case is going to be what? Our acceleration is going to be what? Negative 9.8 what meters per second squared. Why? Because our acceleration always acts downwards, and now we chose upwards as positive, so we are opposing it, hence it has a negative sign. Here the question is, okay, why here did we put positive instead of negative? Because now we chose downwards as positive. Okay, even if here we chose downwards as positive, it means now acceleration was going to be positive. But in this case, I want you to do this. Always choose the choice of direction with regards to what? With regards to where your ball started moving towards. Okay, yes. So now let's draw the acceleration time graph. So, so acceleration time graph, which you consider an easy graph. Okay. This is time in seconds. This is acceleration, the off in what? In meters per second squared. It is very important to label in full. Now, this is very important. You just check, okay, my object is moving upwards, or rather, I chose upwards as positive, and it means my acceleration will be negative. Then I just come here and say, okay, this will be like this. Then I'll just come and say this is negative 9.8. Just 9.8 because I've already indicated the SI unit. I'm done. Hence, I said the acceleration time graph is just be the easiest. Now, I come back and say, okay, let me draw the, what's this? The position time graph. Why am I choosing this axis like this? Because now, can you see, it started from that height and it came back to that initial height. So if we take this height that it started at here, this height, SH is equal to 0 meters, then it's gonna go to the what? remember this point here. This point here, I said it is what? This is the maximum height. I said that is the maximum height. And remember what is the what happens is the maximum height? I said the velocity is 0 meters per second at maximum height. What I said. Here, we're going to use the analogy of window. Okay? I want us to use the analogy of window. What does window say? Window. It says now velocity increases as you move down. I repeat. Window says velocity okay, V for V, velocity EIN increases as you move down. Okay, as you move downwards, the velocity does what? Increases, meaning as you go up, the velocity does what? Decreases. But when you move downwards, the velocity does what? Decreases. Why? Is it true? Yes, because can you see now? Can you see now? The velocity as I move upward, what happened to it? It decreased, okay? Then it eventually got to 0. But from this point, maximum height going downwards, what happened to the velocity? The velocity increased. Just check the magnitude. Never mind the negative sign for now. The magnitude increased, okay? So it tells you that as you move down, velocity increases. So now this is what now window is trying to tell us, okay? This is the analogy that we use, all right? Now, if you know how to draw the trajectory, or it is moved upwards and now returned back to its initial velocity, that is exactly what you're going to draw for position time graph. The trajectory, it is exactly what you're going to draw for what? Position time graph. What do I mean by that? Your trajectory you saw, it is like this again. Then this is your position time graph, klar. You'll just come here and say this is time in seconds. This is changing y in meters. Then you say it started here at 0, it went up to maximum height, it came back like that. Can you see? Only this one is different because now we chose what? We chose downwards as positive. And now as we chose downwards as positive, the height increases thereof. But now, if you chose upwards as positive, in this case, if you chose upwards as positive, the graph was going to be like this. For the position was going to be like that. Can you see it follows the very same trajectory? Okay, but this one, do not stress more about it because they do not want you to draw it. Okay, it's just important for a method of multiple choice questions. But when I start from scenario 2, you might be in a position where you have to sketch it. Okay, this point here, it is the point that we refer to as H max, maximum height. And I want you to take note of something. The time in here, this time here, T1. Let's say this is T0, this is T2. The time from here to there should exactly be the same from the time from here to there. Exactly equal in length, okay? Meaning T1 minus T2, T0, T1 minus T0, it is exactly equal as T2 minus T1. These time intervals here are equal. Even if I were to cut it like this, okay, those times are equal, okay? What do I mean by that? If it took from here to there, from here to here, if it took me 5 minutes, 5 seconds, it means from here to there, it will also take me 5 minutes, 5 seconds, okay? If it took me 5 seconds to move from this point up to that point, then it means now it takes now exactly that time to go back to the original position. Can you see now that this is the easiest then this is the second most easiest, because now if you know how to draw your trajectory, you know exactly how to draw your graph. Let's look at the last one, velocity time graph. I want you to look at this very, very carefully. I want you to understand it when I'm going to be explaining it to you right now. Okay? I want you to understand this very, very importantly. Where does your object start? Now, you are not told whether the object is, okay, let's say it is projected upwards with a velocity of v, okay? Upwards with a velocity of v. It was thrown upwards, okay? So if it was thrown, it means it has a certain velocity, okay? Remember, this velocity that is thrown upwards with is going to be the same velocity that it reaches the what? The hand with, okay? But now in opposite direction. What do I mean? Remember here, I said if it's going to go up with initial velocity of 39.2, it's going to come back with the same initial velocity of 39.2, but now we're in opposite direction. So how does this help us? It helps us to say, okay, we started our trajectory, and can you see now it is equal length? Equal length. So here it should be equal length. So what do I mean by that? It means now I start here at velocity v, because this did not start at with a velocity of 0, okay? It started with the velocity of v, then it went what? I want you to see something. As it went upwards, what happened to the velocity? The velocity decreased until it reached the velocity of 0, okay? As you moved upwards, the velocity decreased until you reach the velocity of 0. So if the velocity decreases, and remember the velocity, oh, let me label, sorry about that, time in seconds, velocity in meters per second. So now, then I'll have negative v somewhere here. If now my object, as it moves upwards, it now decreases. Remember here, at this point, v is equal to 0. Then here, v, then here, negative v, whatever the values that the examiner might give you. Okay? So it starts here. Remember, for velocity time graph, it's just a straight line, okay? A diagonal one. So it starts here and goes where? It goes there. Yes, we chose upwards as positive in this case. Okay, we chose upwards as positive, but can you see as we move upwards, what happened to the velocity? The velocity decreased until it reached the velocity of 0. Hence, we are saying now the velocity moved from v until it reached negative, it reached 0. Okay, this is the maximum height. This is at maximum height. Why is that at the maximum height? Because now the time, and this is also time t1. Okay, if you were to look at from this sketch. Do you agree with me here at this time here, at this maximum height? What did we say about the velocity there? The velocity is 0 because it will stop momentarily. Okay, it will stop momentarily before it goes where downwards. So hence we are saying, okay, as it moves upwards, the velocity does what? It decreases like that. Okay, then until it reaches 0. After reaching 0, it does what? Remember, what does Windows say? What does Windows say? Windows say velocity increases as you move down, okay? But now, since when you choose upwards as positive, it means it's going to increase, but we're in an opposite direction. So something like going to increase, but we're in an opposite direction, like that. Like that. So this will be time t2. Okay? And now one thing I want you to take note of, from v to 0, even if you are asked to draw this, it should be equal length from 0 to v. It should be of the same equal length. Why? Because now the distance from here to there, okay, it is exactly equal to the distance from there to there. So it means, what does this tell us? It tells us that the displacement is 0. Why? Because you moved 5 meters upwards, and then you moved 5 meters again downwards. So when we talk about distance, distance is going to be 5 meters plus 5 meters, which is just 10 meters. Okay. But when you talk about displacement say it is x final minus x initial. What is x final? X final, it is 5 meters. Okay. I think, let me see. Choice of direction. Mm, I don't know. But yeah, okay. Now, what will happen is that, okay, it's going to move 5 meters downwards plus 5 meters upwards. Remember, when you talk about displacement, we now consider the direction, which is the sign in this case. But when you talk about distance, we did not care. Okay, we just added further the number. So this will be 0 meters. The displacement. Okay, so this is basically that. Hence, I said now the velocity time graph, it is the one that is a little bit trickier. Okay, you have to just think, as my object is moving there, what happens to its velocity? Okay, it is decreasing. Is it increasing, decreasing? Okay, now let's look at case 3, or rather scenario number 3. Okay, we looked at the first scenario, we look at the second scenario. Now let's look at the third scenario. The third scenario says now an object is thrown vertically upward from a certain height and did what? And and an object is thrown vertically upwards from a certain height and allowed to fall to the ground. Okay? What do they mean by that? So it means now we have our ball. It was thrown vertically upwards, or instead of using thrown, I'd say projected. Okay? Projected upwards. Then it means if I were to draw this, I might say, okay, my ball was allowed to be dropped from a certain height. Sorry, not to be dropped, to be thrown from a certain height, right? Here's that ball. It is thrown from a certain height. Okay. It goes up until it reaches this maximum point. Then it will do what? It will come back. Can you see that? But now it is allowed to do what? To fall to the ground. Is allowed to fall to the ground like that. Can you see what happens? Now our ball is moving upwards, then blah 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 blah. I want you to check from here to there. It is the same position. It is the same as throwing it upwards, then catching it on the same position. But instead of doing that, they allow it to move downwards like that. Okay? Yes. This one is going to be important. The examiner should tell you which reference point you should take. Okay? Now, if the examiner says now the reference point is the 0 point, take note. Reference point is the 0 point. What do I mean? If the examiner says take take the height as take the height as the reference point, it means this is going to be your 0. It means your graph will start there, then it will go up, then it will go downwards like that. But if the examiner says take the ground as a reference, it means now you'll draw your zero reference here, then like that. Okay, I'll draw those two cases. I was explaining something. The velocity here, it will be the same as the velocity in where? In there. But in what? In opposite direction. But do you agree with me? Here it will be what? V max. Okay? Why? Because now the velocity, the negative Vmax, because now the velocity increases as you go down. Remember, Windows says velocity increases as you move down. So now the choice of direction, you're going to choose what? You're going to choose upwards as positive. Why? Because our motion started going upward. Okay? Upwards as positive. So if that's the case, it means now when I draw my, remember, if I choose upwards as positive, what is my acceleration? My acceleration is going to be what? Negative 9,8 meters per second squared. Okay, yes. Okay. Sometimes the examiner might tell you draw the what graph, take upwards as positive and what is positive. So this one is just straightforward. You took upwards as positive, therefore it means the value of acceleration will be negative. Like that. This is acceleration in meters per second squared. The value is negative 9.8. This is time just in seconds. Now I want us to draw the position time graph on two occasions where you take a height as reference, also where you take the ground as reference point. Remember I said this trajectory that you have drawn for yourself, it is exactly what you're going to draw for the what? For the position time graph. Why am I saying that? You'll see. Let's consider the first scenario. The first scenario, they say you take height as a reference. So height will be your 0 point. I want you to come to your trajectory and say height will be your 0 point, meaning here will be your 0 point. It means now you'll draw your axis there. Will be your 0 point. Then your axis will go like that. Okay? This is what I want you to draw. It means now you're going to draw something like, why? Because you took height as reference. Remember I said reference point, it is what? 0 point. So can you see it is 0 point, the height. So this is what you're going to draw. Let me show you. You come and say, okay, I just try to copy everything there and say, okay, this if, let me redraw that. If this is going to be maybe my height there, here, okay, then I'm going to do what? Can you see what happens? I start there at this point, and then I do what? I draw again. So I'm going to say, oh, all right, that's interesting. So it means here I'll be having now time in seconds. Here I'll be having change in y in what? In meters. My height, I take it as a reference point. So it means I will start where? I will start here, go up, reach maximum height, come back, and then boom. This is what you're supposed to draw. Can you see? It is exactly that, okay? When you take height as a reference. But now what if the examiner says now, take, this is maximum height, by the way, just H max, H max, H max, ah, I don't know why these things keep on doing this, okay? This will be H max here, okay? So this value here will be H max, okay? Then this will be the height, the height here, okay? Then this is us coming back. Then it going to the ground. But now what if the examiner says take the ground as a reference point? When the examiner says take the ground as a reference point, it means now the graph, your ground will be a 0 point. It means this will be a 0 point. This will be your x-axis. Then it means your y will just move upwards because your graph will just end there. Can you see? So it means what you'll draw, you'll say, okay, I start from a certain height h, then I move in that like that. Can you see? So, if I take ground as a reference, it means now I'll have to draw a graph like that. So it means in this case, I'll change the axis and do it like that. Rather than doing it like this, I'll do it like this. Rather than doing it like this. Why? Because now I'm gonna end where at the ground. Okay, the ground is the reference point, and I'm gonna end there. So it means I'm gonna still do the same trajectory, but now can you see what happens? It starts the certain height, then it comes back there like that. So this is exactly what you're gonna draw. This is exactly what you're gonna draw and say, okay, we started at a certain height. I'll just name it here, certain height h. Okay, we went above and reached the maximum height, and then okay, I think this is a little bit far. Like that. Okay. We went upwards and reached the maximum height and then did what? Went to the ground. This is exactly the same graph. What differs is that now the position of the reference point. The position of the reference point is the one that is giving us what? Problems now. Okay? Yes. It is exactly that. Just that what gives us the problem, it is now uh, the reference point. Okay, I want you to understand the reference point part. Now let's draw the velocity time graph and see if we understand that. Okay, I'm gonna sketch the velocity time graph here. I'll try to squeeze everything there. When you draw, it is very important to remember your choice of direction, whether you choose upwards or downwards as positive. This is time in seconds. This is velocity in meters per second. Now, here they said is drawn vertically upwards or it is projected, right? So if it is projected, it has a velocity of v. Then here it comes back with an initial velocity of negative v, or not necessarily final velocity, but velocity of negative v, which is the same in magnitude as that one because it is the same position. Then as it goes down, the velocity will increase more, but in the opposite direction. This is what Vindo tells us. Velocity increases as you go down, right? So it means, okay, we start at velocity v, okay? But what happens as we move upwards like that? Okay, we're gonna have a trajectory like this. As we move upwards, what happens to your velocity? It decreases until it reaches what? Maximum height, okay, where velocity is 0. So it means, okay, it's gonna move from this point to the velocity of 0, okay? But after moving to velocity of 0, can you see now here, the velocity will be the same in that cases. The velocity will be the same, but now in opposite direction. So you're gonna, okay, let me try to label. This is the time for it to reach the maximum height, T1, this is T0. This is the time reached to, T2 is the time reached, taken rather to reach the initial height, time taken to come back where it was projected. Then this one, it is the T final, the time taken now for it to hit the ground. T3. Similarly here, if I were to label, this is T0. Then here, exactly in the middle, exactly in the middle, I have T1. Then I know, okay, here and there, the time will be, okay, my sketch is not drawn to scale, but this is T2. Then the time final, it is T3, like that. Okay? Now, as I was discussing that, here the velocity will be 0 at the maximum height. Okay? Then after doing what? It will go back to the original velocity, but in the opposite direction. So it will move from here, sorry, to there in an opposite direction. Can you see what I've just drawn here? Remember, it does this. What I've just drawn here, it is from A, B, C, D. It is also important to label this. Do not label it, just so that you see. This is just A, where it started. This is B, the maximum height. This is just C, where it came back. Okay, why? Because the length here, it is equal to the length there. But remember, we are still short of C to D. So how can I draw C to D? I just extend this line and say, it just reached V, Vmax. It just reached what? V, Vmax. Can you see? Now the difference between this graph and this graph here and this graph here. Here is that it started there and it came back to the original position. Hence now the length, this one is equal to that one. But so. But for this one, it's gonna be different. Why? Because it started there, then it went back to the original thingy, then it went to D. Now can you see now the size is not equal? Okay, yes. Okay, yes. Very nice. Very nice. Now, let's have now special cases, okay? Let's have special cases where now our ball bounces. Bouncing ball. Now I want you to take note of something. As the ball bounces, before you draw, as the ball bounces, it loses. I'm not sure if loses is written like this. Loss. Oh, Dimo. Lose velocity. Okay? Also lose energy. What kind of energy? Loses energy in a form of heat and or sound. Okay, yes. Now let's consider, okay, let's consider now the bouncing ball. Let's say we have a ball that is dropped from this height, okay. Should we just say it is dropped? Okay, let's say it is projected upwards, okay. Let's say it is projected upwards from that height. And this is my ground. And let's say now, here is that ball. The ball here, the person standing there, projects the ball upwards. Then the ball comes back like that. Then it bounces. Remember, when the ball bounces, does not bounce to the original height. We can all agree on that, right? Why? Because it lost energy. Okay, and the velocity is lost. Let me repeat that. It will do that eventually, and eventually will. Can you see now? As we bounce now, what happens? The velocity now changes now. But what I want you to take note of is that the velocity here that it comes with, this velocity here will equal to the velocity at B. Then it will go up. Remember, on these occasions, the V is 0. V, it is equal to 0. On these occasions, V is equal to 0. Okay? Then it will come with the velocity of c. The velocity of c, it will be the same velocity that it goes upwards with, right? So now the question is, how do I draw now the velocity time graph as well as position time graph? Well, for position time graph, we already know that we are sorted. What do I mean by that? It's because now we know that, okay, we're going to take exactly that trajectory. Let's say we take the ground as a reference point, okay? Let's take ground as a reference point. Ground as a reference point. Remember, reference point, it is the 0 point, okay? So if that's the case, remember for changing y in meters and time in seconds, you'll just take everything as it is. So you'll say, okay, it started at a certain height, h, then it went above and it came back like that, like that. Okay, let me try to minimize that. Like that, like that, and whatever. Now, let's say now they say there is a contact time, okay? If there is a contact time, it means now it will come and bounce, and after a certain time, it will like something like it will go up and return. Then if there's a contact time, okay, like that. Okay, yeah, just this is just ending at maximum height. Then the velocity time graph will be a almost nice, but I want you to take note of it. It's interesting, okay? It started where? At a certain velocity, right? Here. At a certain velocity here, right? So yes, it started at a certain velocity, v, okay? Then it went downwards. So it went to the maximum height. We agree on that. It went to the maximum height, then it returned back to the original thingy again. It returned back to the original thingy. Okay, actually, which thing are we taking as reference point here? Downwards or upwards? I think we're gonna take upwards as positive because it started upward. So it's gonna be like that. Then okay, it's gonna go back to the original position, but in the opposite direction. Again. Okay, I think I've drawn into it a little more now. But you leave something like this. Start here, goes to the maximum height, from maximum height to negative v. There, then it will extend a little bit to reach Vmax. What do I mean by Vmax? Vmax is the velocity that it reaches here. Yeah? Then, if there is a contact time, whatever that will happen. Now, can you see after here, after reaching Vmax or let's call it Vmax, after reaching Vmax, it does what? It goes up. So it means now it will start with a new velocity that will be less than the original V. Like that. Okay, that will be less than the original V. Similarly, less than this one, okay? Less than this one, less than this one. Can you see? It is no longer returning to the original size. So it's gonna do this. Let me note like that. Okay. Then after reaching that value there, it will go up. Okay, this is us showing you it will go up. Okay, it's gonna start where it's supposed to go up. Then okay, here it is point. Let me label this. This is A, then it returns to B. This is C, this is D, this is E, this is F. So here it will be where it starts at A, then at okay, I think I labeled this not so good. B is very important, the maximum height. C is where it comes back. F, E, G. A, it is where it starts, okay? B, it reaches the maximum height for the first time, okay? Then C, it is where it reaches the very same velocity here. Then D, it is where it reaches the maximum height, okay? Then, okay. Then, yeah, the velocity, remember the velocity as you, oh, or in this case, I've drawn this wrong because now why? Check. The velocity that it reached the ground with here at D, it is the very same velocity that is gonna increase, go up with, okay? Even though velocity is lost, but it's gonna be a little bit tougher. On this one, they do not need you to draw them. You just need to interpret them, okay? Lot higher velocity, then it will come back, but with a decreased velocity, so something like blah, 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 and then goes like that, okay? So now, this is what you mean by now the special case of bouncing ball. The last one, before now we move on to examples of calculations now. The one that I like is now hot air balloon. Hot air balloon. Remember how does a hot air balloon? A hot air balloon is something like, I always struggle to draw this. Okay. I don't know why I always struggle to draw this. Let me try. Maybe this time I might get it right. I might get it right. Okay. Then this is not a globe, but it is a hot air balloon. Okay. It is a hot air balloon, not a bulb. I don't know how to draw, but this is a hot air balloon. Okay. Now a hot air balloon now has something that projects it upwards. Okay. Now hot air balloon, you should be told it moves at a constant velocity. Constant velocity means what? Acceleration is equal to 0 meters per second squared. So now, the hot air balloon, it is. Why are we saying the hot air balloon is not in free fall? Because now, what is free fall? Remember, free fall, it is motion of an object under the influence of gravitational acceleration only. Is the blue ball moving under the the influence of gravitational acceleration? No. Why? Because we know that the hot air balloon takes out some gas, okay? Gas that propels it to move upwards, okay? So now, can you see now the forces acting now? It is now Fg, Fg, as well as the force of the gas. Can you see now? Two objects are moving on this hot air balloon. So it means now it is not on free fall. Another thing that is not on, why we are saying it's not on free fall, they like to say it is moving at a constant velocity. And if it is moving at a constant velocity, its acceleration, it is how much? 0 meters per second squared. And remember, for a free fall, for it to be on free fall, here, it needs to go it needs an acceleration of 9.8 meters per second, but in this case, it is 0 meters per second squared. They won't tell you the acceleration is 0 meters per second squared. They'll just say it is moving at a constant velocity. Therefore, it tells you that, okay, acceleration, it is how much? 0 meters per second squared. So that maybe they might say, okay, the ball, okay, here's the person holding a ball. Okay. Then remember, okay, it is moving upwards. Okay, moving up. What's moving upwards? It is now the hot air balloon. Take, listen to me very carefully. The hot air balloon is the one that is the hot air balloon, as well as the person, as well as the stone. Just before the stone was dropped, it is now moving at a constant velocity, moving upwards. So it means now all of this system is not on free fall. Okay, but now let's say it is moving at a constant velocity of 5 meters per second. Okay, so it means everything in that object. Remember, if you're moving with the car, let's make an example. If you're moving inside the car is moving at a speed of 120. It means you know you're moving at a speed of 120, right? Yes. So this is the case here. So the man holds the ball here, and they are all moving at a constant speed or constant velocity of 5 meters per second. So now, then at an instant, the ball gets maybe the ball is dropped. Okay, the ball is dropped. But now I want you to think about this. When the ball is dropped, it won't just necessarily go boom downwards. Why? Because due to inertia, okay, what is inertia? Okay, remember inertia is now what? The tendency of an object to resist change in motion. Meaning, if an object is at rest, it wants to be at rest. It is very hard to keep it going if it's at rest. At rest. If it is moving at a constant velocity, it wants to move at that constant velocity. It does not want to change. Okay, this is what we refer to Newton's first law. Remember, the definition says so. Okay, I just drinking water. It says now an object will remain in its state of rest or motion under the motion at constant velocity unless a non-net force acts on it, right? Right? So now, when this ball is dropped from this height, due to inertia, it still has that thing, you know, I'm moving upwards, ne? Until it reaches, remember, okay, immediately after it is dropped, immediately when the stone is dropped, it is now moving under influence of gravity because now it will be now moving upwards a little bit on its own due to the inertia it has. Then it will do what? It will move upwards a little bit and then it will go to the ground like that. This what happens. Now the question is, okay, I heard myself carefully when I said it is dropped. Okay, was dropped, but now because all this time it was moving at the velocity of 5 meters per second, moving upward with the hot air balloon. All when did I remove my thing here? I can see, man, something is not right. Okay. Since while since while they were moving all at a velocity of 5 meters per second, even though it is dropped, ne, but it will be. Can you see? Hence, I'm saying it will move upwards a little bit. Why? Because it still has that velocity of 5 meters per second. Before now, gravity acts on it. Okay. Can you see now? Only gravity acts on it. So with that velocity of 5 meters per second, trying to go upwards, it will reach what maximum height, and then it will eventually go downwards. This is a scenario that we really see that we cannot necessarily try to demonstrate by just maybe making an example of it and trying to see it with our naked eyes. But now it is a theory that you need to understand because now I'm telling you as it is dropped from a moving hot air balloon, it's gonna move it. The initial velocity is already now what 5 meters per second, and it will reach 0 meters per second maximum height. Then it will move downwards. Okay, but as it is moving downwards. The hot air balloon continues to move upwards, and the hot air balloon is not under any the hot air balloon is not under free fall unless they say the gas now is finished. When the gas is finished, that propels it up. It means now it will undergo what free fall, because why? They will be only what uh, only gravity will be acting on it again when the gas now is finished. But for the fact that the gas is not finished, it means now the hot air balloon is not moving under a free fall, but now at an instant the stone is dropped, it is now under free fall. So if they were to say draw the velocity time graph and the position time graph, position time graph will look like this. Let's say they say take ground as reference, it will look like this. It started at whatever height that the hot air balloon was. At an instant, it was dropped. Then it went up a little bit. Then it came back to the ground. Okay, this is just the position time graph. Okay, it went up. People, I'm telling you, it went up. Why? Because the theory of inertia tells us that an object, if it has an initial velocity and it is moving, let's make an example. Kawen, if you're moving in a car and then you decide to hit the brake, isn't it true that you still have the velocity of 120 meters moving in that direction? When you hit the brakes, especially for an emergency, you're gonna move forward. Okay? Why are you moving forward whereas you hit the brake and your car is moving backwards or is stopping? It's because now why you have inertia. Okay, your body is still under what that velocity, hence you move forward until you come back. Okay, so this is exactly what happens. I'm not lying to you, people. I'm telling the truth. Then, yes, this will just be changing y in meters. Then this will just be time in seconds. Then what if they say to us, draw the velocity time graph? When we draw the velocity time graph, we'll say, oh, that's good, fine. We understand that they said it is dropped, ne? We understand that statement. But now the thing is it had the velocity. Okay? It had the velocity of whatever velocity of the hot air balloon. Okay, this will be the velocity of the hot air balloon. Speed. Okay, this v. Actually, let me do this. Then after having that initial velocity of v, which is the hot air balloon speed, it went to the maximum height. Then it said, okay, it went back to the point where it was projected, or rather dropped. Okay. Then after reaching that point, which will have the very same value, but now in opposite direction, then it will continue moving where downwards, where it will reach negative V max. Okay. Okay. This is what is happening in vertical projectile motion, but DEMO. Okay. Yes. Let me try to get now examples thereof that we will need to use so that we do not just only practice, but now also rather let's not just only talk, but rather do more practices. Okay, yes. All right. Okay. Now, remember I said I'm gonna be doing questions. Okay, so I just wrote out down the questions. We'll just look at those questions there. Now, what I want you to take note of is that the slope, or rather, yes, the gradient of the velocity time graph. Okay, the slope of the velocity time graph, it is now your acceleration, which is your g, and it is negative 9.8 meters per second squared. Okay, your gradient, okay, your gradient for the velocity time graph, it is acceleration or gravitational acceleration, and with a value of -9 meters per second. Why? Can you see now that it is slanted backwards? So it means now our gradient, it is negative, like that. Yes. Similarly here, the velocity time, the slope of this one, it is velocity, but they won't ask you about that one. The one that they like, it is the one with regards to the velocity. The slope thereof, it is what? It is acceleration. Now let's look at the questions that I created here. I think maybe, I know the English won't be perfect, but for the purpose of practice, they will be beneficial. All right. Now they say an object is projected vertically on another. Before we go anywhere, let's now define what the term projectile. Okay. The term projectile now means now projectile. Okay. Projectile. Do they call it projectile, or what do they call it? I think it's projectile. Yeah, projectile. Projectile. What is projectile? Projectile, it is the motion. Oh, so. Let me quickly find that word before I give you anything that's not correct. Where's that document? For terms and definitions. Let me quickly look at it without wasting any of your time. Okay, what's happening? Okay, you just give me a moment. Just a moment. Right, yes. Here it is. So now, the word that I'm looking for, it is now a projectile. So what do you mean now when we say something is it projectile? Why is my document taking time now to do this? Let me do this. Okay, yes. Now the word that I'm looking for, it is indeed projectile. So we say projectile what? We say projectile, it is an object. Okay, projectile, it is an object that has been given an initial velocity and what does it say? It is an object that has been given an initial velocity. Okay, initial velocity, and upon it is an object that has been given an initial velocity, and upon which only gravitational force acts on it. Please make use of the definition that your teacher gives you or that you take from the exam guideline, okay? But now the important part is that when we say something it is projected, we are talking about an object that has been given an initial velocity. When you say it is projected, it's like we are saying it is thrown, okay? So when you throw something, you are giving it the velocity that it should be traveling with, right? So it is an object that has been given an initial velocity and upon which only gravitational force acts on it, okay? So to show that it is still under free fall and it is projected, it means now gravitational force is the only one acting on it, okay? So now let's look at this one. An object is projected vertically upwards from a height h of 40 meters, okay? Height h of 40 meters at a velocity of 10 meters per second, okay? Now, the first one they say now to us, okay, before I do this, I want you to be in a position of drawing down the trajectory, okay? Try to draw the scenario thereof that happens. An object is projected vertically upwards from height h of 40 at a velocity. So it means the scenario that you might have, remember the examiner will give you the sketch, okay? Now here I'm trying to teach you how to become independent. Now we are answering now. So we might say this is a height of 40. Okay, remember we do not want, we are not doing this for beauty. Sorry about that. The height here, it is how much? 40 meters. Then what happens to that ball? That ball, it is projected upwards, okay? At a velocity of 10 meters. Okay, let's assume that the examiner told us it until it reaches the ground. Okay, and then it reaches the ground. Let's assume that the examiner tells us that, okay? Yes, I forgot to mention that it reaches the ground. Now, what I want you to do is to divide your motion into parts. Say this is A, this is B, the same point here, C, then the last part it is D. This is going to help you a lot. Trust me. This is going to help you a lot. Bring back. It's going to help you a lot. Okay. Now, let's answer the question that is being asked to us. They say calculate the time taken to reach the what? The maximum height. Okay? Time taken to reach the what? The maximum height. So it means from here to reach the maximum height. So when we answer A, we're gonna focus from A to B. This is very important. Why? It tells you now the path in which you are focusing on, right? And remember what we said about here. The velocity is 0 meters per second. The examiner will never tell you this, but this is very important. At B, the velocity is 0. Now, first thing first, before we go anywhere, choice of direction, it is moving upwards, right? So we're going to choose upwards as positive. But if we choose upwards as positive, what is our acceleration? It's going to be negative 9.8 meters per second squared, because why? It is moving downwards. Okay, now we chose upwards as positive. So now they want the time taken to reach the maximum height from where it started, okay, until it reached the maximum height. So actually, as our label, it means we went from A to B. But now, what is velocity at A? We know the velocity at A is how much, which is the initial velocity. It is how much? It is 10, okay, because they told us it is projected from a height of 40 meters at a velocity of 10 meters per second. Now they want to know the time taken to reach point B. Now what I want you to do is that collect your data. First thing first, you have A, it is negative 9.8 meters per second squared. Okay. The second one, you have a initial velocity. You are given as 10 meters per second. Okay. You are required to find what time. This will be unknown. Remember, I said you need 3, then the fourth one you'll find. Then now you have what? You have this is the most important information, that at maximum height, you have what? You have the velocity as 0. So you're going to say, okay, velocity final, we are referring with regards to B, is going to be how much? 0 meters per second. Now, do you know the height from A to B? No. So the change in Y, we do not need, we're not going to use, hence I do not include it. Then I find a suitable formula that's going to suit this thing here. And when I look at that formula, I see the formula is that Vf is equal to Vi plus A change in time. Please show the examiner that you chose upwards as positive. Okay? When you chose upwards as positive, what is your final velocity? Your final velocity is at the maximum height, it is 0. Initial velocity, it is 10. It is positive. Why? Because it is moving upwards and we chose upwards as positive. Plus acceleration, it is negative 9.8 meters per second squared. Then change in time, it is what we are looking for. Okay. Then when I take negative 10, okay, 10 to the other side is going to be negative 10, 9.8. Change in time. Then now change in time is going to be when I divide both by negative 9.8, my time will be something like 10 divided by 9.8, something like it took 1.02 seconds to reach the what? The maximum height. So where is your mark? Your first mark is writing your formula. The second mark is substitution of everything. Your final mark, it is your answer the off. So this is the time taken for us to reach the what? The maximum height. The next question says, calculate the maximum height above the ground. Okay? The maximum height above the ground reached by the object or by the ball. So now the examiner is asking us, calculate the maximum height above the ground reached by the ball. So which is the maximum height? This one, above the ground. So the examiner does not say calculate from A to B, from A to the maximum height. No, with regards to the ground, from the examiner said find the what? Find the maximum height from the ground. So it means it's gonna be height H plus height from A to B. Height, this one. So this is the maximum height from the ground. So first thing first, how do I tackle that question? So this was A, right? So how do I tackle that question? I'll say, okay, I already know this distance here, from here to there, to the ground, okay? But this is not the maximum height that the ball reached. The maximum height the ball reached, it is point B. So it means I need to find the distance from here to there, okay? How can I do that? How can I do that? I say, okay, let me find height from A to B. Okay, it is how much? Because the height from A to B, it is this height. Then we'll just add it to 40. Then this is the maximum height it reached. Okay, so we'll say, okay, we're coming back for A to B. But in this case, for now, we are looking what? At changing Y. We want what? Changing Y from A to B. It is what we are looking for. We have what? Acceleration of negative 9.8 meters per second squared. Do not change your direction and say now you are taking downwards as positive. If you have started and chose upwards as positive, stick with that direction until, okay? Then we have initial velocity of 10 meters per second. Then we have the final velocity of 0 meters per second. You can also use change in time in this case, but I won't need it. Why? Because I just need this, because I like using the information that I already had. That's the one, not the one that I calculated, okay? But you can also use time. But if I use the formula here, when I check, I'll have, okay, Vf squared is equal to Vi squared plus 2a changing y. Then what is my Vi squared? My Vi squared is 0. Then what is my Vi? So Vf squared is 0. What is my Vi? It is 10 squared plus 2. What is my A? Negative 9.8. Can you see now? I also chose upwards as positive. I'm going to choose upwards as positive until. Then what is my change in Y? I don't know. I come and take this negative. Can you see what I do? Negative, but the bracket is still there. It is equal to, what is this? 2 multiplied by negative 9, it is negative 19.6, change in Y. Then when I want my change in Y, it is how much? 10 squared divided by 19.6. I get a height of 5.1 meters. But now remember, the examiner did not say calculate the height from the what to the maximum height. The examiner said, what is the maximum height from the ground to the what? To the from what is the maximum height from the ground, I get reached by the object. So now initial velocity, it is positive. Why? Because you chose upwards as positive, I get ahead. Then The answer here, it is positive. Why? Because now the height that we are calculating, it is above point A, okay? So anything above point A, it is going to be positive. Anything below point A is going to be negative. So when I want H max, maximum height, I'm going to say this is 5.10 plus the 40 meters. Then it's going to give me 45.1 meters. So this is the maximum height reached, okay? If you chose downwards as positive, the answer that we're going to get here, it is negative. But when you come here, just take it as positive, because why? We are wanting our height. Height is the same as distance. It's just the value, okay? So in case when you use the formula that has changed in time and it does not have this one, it's fine. It's fine. You'll get the same value, okay? You'll get the same value, okay? Yes. Then how do they mark this? They say formula, substitution of everything here. Then now taking your H here and adding it with 40. We do not mark your change in Y here, but rather we'll mark it here, where you have added it with 40, everything. Then your final answer it is 4 marks. Okay? Yes. C says give the magnitude and direction of the acceleration at the maximum height. Okay. The direction and the magnitude and the direction of the acceleration at the maximum height. At the maximum height, what is our acceleration? The examiner said the magnitude and the direction. So what is our acceleration? Remember our acceleration, it is g. So at maximum height, what is our acceleration? Remember I said always, everywhere, your acceleration is going to be magnitude of 9.8 meters per second squared. Now, why are we not including the negative? Because now the examiner said the magnitude and direction. So the direction is what? Downwards. So, and your acceleration will always be 9.8 meters per second squared downwards, whether it is at the maximum height, whether it is at a point where the object is moving downwards or what. Remember I did explain here where I said this one, it is always downwards. Okay? Hence now we are putting what? Negative, so that it shows us it is moving downwards. But now, if the examiner says the magnitude and the direction, you just say the magnitude is 9.8. Remember the magnitude does not have sign, okay? Magnitude is just 9.8. The direction is always downwards. Always downwards. So if that's the case, we have answered the question thereof. Then let's look at the last question for that particular one. It says, draw the position time graph showing the motion of the ball from an instant it was projected until it hit the ground. Okay, there's something I forgot. I'll add it. Take ground as a reference point. Okay, so now you're going to draw the position time graph, okay, showing the motion of the ball from an instant it was projected until it hit the ground. Take the ground as a reference, very important. Now on your graph, the examiner will tell you what to show. The height it was projected from, time taken to reach the maximum height, and now time taken to reach the ground. So remember, us drawing this makes us to be in a position of drawing the position time graph. Why? Remember I said if you have the trajectory, the path, this one, you already have the position time graph. The examiner said take ground as reference. So if ground is reference, this is going to be your x, then this will just be your y, like that. Then this will be your motion. So let's try to execute that. Basically, let's try to execute that. Okay, so we're gonna have, and we're gonna say, okay, This is just straightforward, nothing difficult. We're gonna start from here up to wherever. Okay, let me repeat that. Okay, okay. Now, what's important is you labeling, okay? That this is position in meters, then that there it is time and seconds. Then now, remember ground is a reference point, so we'll just put anywhere further, just put height. Remember the height is 40 meters, okay? Okay, let me erase that and put it somewhere again. Oh, let's say the height is somewhere here, okay? 40 meters, okay? Then it goes way upwards and then it does what it comes, okay? Try to draw it in a more nicer way like that. Good. I think this is perfect. Then now, you have already shown the examiner what he or she wants. What? The height. You're going to get a mark for showing what? The height. It was projected from. 1 mark. The second mark is you showing the what? The first mark is here, showing the, and the second mark, the time at maximum height and the time at the ground, with the ground. I did not give it to you. Okay, it's fine. So at maximum height, you know here, this is going to be how much? 1,02. We did calculate that, right? The time taken to reach the maximum height, right? Then this here will be the time to hit the ground. Just say time t. Let's say maybe they required us to calculate in whatever calculation. This one I just created it for myself. So yeah. So it's gonna be that. How do they mark? Okay. I have to do this. I don't know why I used this one. So it's gonna be okay at the maximum height. Okay. We know the time there. The time there it was 1,02. Then this here will just be time. Okay, because we did not calculate it. You get a mark for showing the time at maximum height. You show the time. You get a mark for showing the time at the ground. Mark for a shape. Then your axes are labeled correctly. Another mark. Or you use the ground as reference point, basically. Okay, your ground as reference point, 1 mark. If you draw the graph like this, a graph like this, and indicated anything like this is the 1,02, and then this is just the time taken to reach the what, and then you showed us this should be okay, this should be 0. Okay, then yeah, then here you'll get 4 out of 5. Why? Because you used the wrong reference point. Okay, you used the wrong reference point, but in this one you'll get your full marks because now you used what, the correct what, reference point, and you labeled everything that the examiner required you of. Okay. So here also 9.8 meters per second squared, mark. Direction downwards, a mark. Let's move to our last example. They say now a hot air balloon is moving at a constant velocity, okay, of 8 meters per second squared upwards. Now, before we move on, what is a constant velocity? What does constant velocity tell us? Constant velocity tells us that acceleration rate is equal to 0. Okay, we are given the velocity of that hot air balloon, by the way. Then we are asked, we are told the velocity time graph below show the motion of the stone from an instant it was dropped from the hot air balloon until it reached the ground and bounced once. How many times? Once, to reach the maximum height. Okay, good. Now, I want us to interpret this. This is the moment it was dropped. Okay, moment it was dropped. And I said the moment it was dropped, okay, let's draw a trajectory for this one. The moment it was dropped, remember what will happen to it? It will move upwards a little bit before going downwards. And they said it will do what? It will bounce. Then it's either it will bounce instantly or it will have a contact time and then reach the maximum height. This is what is going to happen. Okay? Yes. So here, this point here, it is the point at an instant it was dropped. Then this point here, it is an instant when it reached the maximum height here at this point. Then this point here, it is this point where it reached the same velocity. So it means this is negative VI. This is us interpreting the graph. Okay, you knowing how to do this, drawing this from the statement, you're gonna have good marks. Trust me. Then this is the velocity at this point that you do not know. Negative velocity at the ground. Then can you see now there was a little bit contact time there? If it reaches then something like that, it tells you there was contact time. So it should be telling us by, okay, there's space there. It means there was what? Contact time. Okay. Then now this point is represented here because now it is in a position of moving where upward. And as it moves upwards, its velocity moves, it's decreasing again. So, and then it reaches the what maximum height again. Okay. So these points are maximum height. These are maximum height after bouncing. Very important. This one is before bouncing. Because can you see it went down until it reached down, then it had a contact time. Then at this point, it is where it went way down, sorry, up to the maximum height after bouncing. So this is where it bounces here. The bounce occurs here. Okay, let me indicate that bounces. Okay. So now another thing happened. The initial, remember I said when the object is moving at the hot air balloon, when now it is dropped. Remember I said due to inertia, because it still have the same speed of 8.6 meters per second that is moving upwards. It will acquire that, it will have that velocity until it takes that velocity and reaches the maximum height, and then it moves downwards. So it means the velocity here, it is 8.6. Why? Because it is the initial velocity, because the initial velocity is the same as the speed of the speed of the what? Of the hot air balloon. Okay, so it means here it will just be negative of that. Let's see the questions. The question says, what does the quantity VI as shown in the graph represent? Okay, it represents the speed of a hot air balloon. Give the value of VI. So now, when we answer that, what quantity does it represent? Okay, it represents the speed of the hot air balloon. And what value is that? The value of it is how much? The value of it is 8.6 meters per second. This is us answering. It shows the speed of the hot air balloon, then its quantity is 8.6 meters per second. Okay? Either way, I just did these questions. I did not take it from any exam question. I just created them because I know the structure that they like to ask. Okay? The second one says, is the hot air balloon in free fall? A very interesting question. Is the hot air balloon in free fall? Now you should consider your answer very well. The answer will be no. Why? Because now the hot air balloon, remember I told you the hot air balloon has what? Has a force that is causing it to move upwards. Okay? The answer there is straightforward. You just say no. Why? You'll say gravitational force is not the only force acting acting on the hot air balloon. Or 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 you'd say no, because it is moving at a constant velocity. And now we know that for a free fall, it does not move at a constant velocity. Why? Because as it moves upwards, its velocity decreases. As it moves downwards, its velocity increases. So as it moves upwards, its velocity decreases. As it moves downwards, its velocity increases. So it is moving at a constant velocity, meaning, okay, you can say it's moving at a constant velocity, or its acceleration is zero. Its acceleration is zero, not 9.8 meters per second squared. Remember, if it is moving under free fall, the velocity, the acceleration, it is 9.8 meters per second squared. But now in this case, the acceleration is zero. Why are we saying the acceleration is zero? It is because it is moving at a constant velocity. Okay, yes. C C says calculate the height above the ground that the ball was dropped from. Okay, so now we'll say, okay, from here, it was the where it was dropped, it went to the maximum height. Again, then it went back to where it was dropped, then it reached the ground. Okay. So now what do we have about the information about the ground? We have the time it took to reach the ground. Okay. The time it took to reach the ground. 8 seconds. Why? Because I'll repeat again. Here it is where it was, here at this moment where it was dropped. It went to the maximum height. How do I know that? Because now the velocity is zero there. Then it increased the velocity in the opposite direction and it reached this point. It went to zero here at maximum height. Then it reached to negative v, where it was the point where it was projected initially. Okay? Then it went where it went downwards to the ground like that. So time taken to reach the ground, it is how much? 8 seconds. Okay. Another thing happy I know is that, okay, I might look from, if I label this A, B, C, D, I might say, okay, let's look from A to D directly. Why? Because I know the initial velocity here. Why? I know the initial velocity here. Okay? And I know what? I know the time here. And another thing that I know is that the acceleration, it is negative 9.8 meters per second. Why? Because we chose upwards as positive. I said you'll choose a direction according to where is your object moving. The object, it is moving upwards. So you'll choose upwards as positive. So your acceleration, it is negative 9.8 meters per second squared, meaning now you have three variables: time, acceleration, and initial velocity. So it means you can get the one that you're looking for. Okay, you have time, you have acceleration, you have what? Initial velocity. You cannot do any calculation if you do not know your initial velocity, because it is very important everywhere. Then we'll want your change in y. Okay, so we'll say the formula that's suitable for this one is that change in y is equal to vi change in time plus half a change in time squared. So remember, we choose upwards as positive. So it means now change in y, I'm expecting the answer to be negative. Okay, then okay, let me change this mark allocation. It should be 4 marks. change it to 4 marks. Then now, what is my initial velocity? It's just me substituting. It's going to be positive 8.6 because it is moving upwards and I choose upwards as positive. My time, 8 plus half. Acceleration, it is negative 9.8. Why? Because I choose upwards as positive and your 8 is acting downwards. So it is opposing 8 squared. Let me quickly punch that. 8.6 multiplied by 8 plus 0.5 multiplied by negative 9.8, then 8 squared. I'm expecting a negative answer. Why? Because now I chose upwards as positive, but now my object, it is moving downwards. So my change in y that I get there, it is what? Negative 244,8 meters. Let's see what the examiner said. The examiner said calculate the height. And you see the height above the ground. So you'll say that negative, you'll therefore say, therefore, height, it is equal to 244.8 meters. Remember the height, it is the same as distance. You do not require what? The direction. So here, here you for no, it is a 1 mark. For saying not only gravitational forces acting on the balloon, 1 mark, or 1 mark for saying it is moving at a constant velocity, or 1 mark for saying that its acceleration is not zero, is 0, not 9.8 meters per second squared. Here, for 1 mark for formula, for substitution, everything correctly. Okay? Everything correctly substituted, then you interpreting the of. Then here, okay, since well you took 8 from the graph, you know how to interpret graph. This will be just 4 marks. Okay, your substitution will be divided into parts. Let's look at the last part. Oh, not the last part. Number D says, where is the ball at time t 9.1 seconds? Where is the ball at time t 9.1 seconds? Where is t time t 9.1 seconds? Here it is. The ball is where? Remember, you check, okay, here it is the maximum height. Why? Because now the velocity, it is 0. So it means now at time t now, at time t is equal to 9.1 seconds. The ball is at the maximum height. You can put after the first bounce. It's fine. But now the important part is that at time t is equal to 9.1 seconds, the ball is at the maximum height. Okay, that is very important. You being able to interpret now the graph. Then I repeat, these questions are just created them by just thinking of a scenario because I know how examiners are. Okay, now they say now, what does the slope of the graph represent? Which graph? This one. What is this? This is the velocity time graph. And I said for the velocity time graph, the slope, it is what? It is acceleration. The question is, what does the slope of the graph represent? Okay. The first part, what does it represent? Okay. Then the other one says, give its magnitude and direction. So we know that the slope represents the gravitational acceleration, which is just g. Okay. Now another question says, after a question mark, what does it represent? It represents the gravitational acceleration, or just g. And they say give its magnitude and direction. Remember, I always said the gravitational acceleration, it is what? Magnitude, it is, okay, let me remove this. The magnitude, okay, this star is going to disturb me. The magnitude of this g, or a, which is equal to g, it is what? 9.8 meters per second squared. This is the magnitude. The direction, it is downwards, or just down. Okay, so the first mark is you saying It represents the gravitational acceleration, and this magnitude is 9.8 meters per second squared, and its direction, it is downwards. So that is all that I had for you, folks. I hope you enjoyed. Let's see what we've been doing. Basically, uh, okay. Okay, now we had the first one here where we introduced everything. Then the second one where we started now interesting stuff. The fourth, the fifth, the sixth, the seventh, the eighth, the ninth, the 10th. Okay, so I want to believe that we had a great session today, folks. Where now we went through the topic of vertical projectile motion. I hope you have an idea now of what is happening. Okay, what will follow up now, it is question papers. Okay, exam question papers that I will take from previous question papers. Remember, I do not like doing examples from textbooks or what. I prefer using exactly what a question papers. So thank you very much, folks, for joining me today in this session. I hope you enjoyed and you'll be able now to apply the knowledge that I shared with you. Okay, especially importantly, the graphs. Okay, the graphs are easy marks that each and every individual of you should be in a position of knowing how to graph. Okay, so thank you very much, folks. Until we meet again. Thank you.